All right, math 335, we're gonna do a little bit of well, quite a bit of some rational P over Q stuff, but we got a question from the audience today. So we're gonna do stuff from 3.3 and 3.4. It's finding the rational zeros of a polynomial. But first, over to my math. This says find a quadratic function f having the graph given shown. And I'm just writing down what the question says real quick and I'll transfer over to the camera. And they've got it's hitting here at 0, 0. And we have a vertex at 5, -1. So it's doing something like this. Well, when we have a vertex, we can take advantage of y equals f of x, which equals a times x minus h squared plus k for a quadratic equation. And we have the vertex. H is 5 and k is -1. So we currently have y equals a times x minus 5 squared plus k would be -1. We don't have a though. We do have another point that we can use. We can find a using our second point. And holy shit, that blue pin is dead. We'll get a new one. Clean classes. And how do we do that? This is x comma y, and we can take it and plug it in for the x and the y. So I'm going to use, I got 0 for my y and 0 for my x. And then solve for a. So 0 minus 5 is -5. Squared minus 1 equals 0. -5 squared is 25. Add 1 to both sides. We get 1 equals 25a. Divide by 25, and we get a equals 1 over 25. So that our equation f of x equals 1 over 25, x minus 5 squared minus 1. All right. So I wanted to point something out in case you guys aren't using it. I had no problem answering questions for this. But if you're at home and you're doing stuff and like you're stuck on a problem, view an example will say the exact same thing. They'll use a different problem. But they had a vertex at a different spot. They still went through 0, 0. It says observe the graph carefully. The vertex is 7, -7. It passes through 0, 0. Substitute the given values in the equation of the parabola f of x equals a times x minus h squared plus k. And it even says exactly how I said it. That's wow. I was wondering if it was going to take a different path than I did.
Is that a formula we should remember for sure?
Oh yeah, this is, yeah, we did cover this in Swiss 3.1. And, oh, you're not seeing what I'm pointing at. That's the same chapter we had where y equals ax squared plus bx plus c. You can write it as that if you find h equals negative b over 2a and k equals f of h. So whatever you get for h, plug it in, and you'll get the k value. But it will help you, and you can use it as a they'll give you a similar example and go, okay, what are they doing on that one? How do I apply it to mine? Viewing examples is really helpful. It can become a crutch. If you use it too much and then you don't learn how to do it, you just copy everything it does every time. You may not learn anything, but it is pretty helpful as a tool in case you get stuck like, I don't even know where to start kind of thing. When I was a student, I'd use it sometimes to just help. I don't know, like sometimes it's a word problem, you're like, I don't even know where they're going with this. So figuring out where they started, I close it or not look at it. You know, try to work on it and only look at it when you need advice. All right. So we had some crappy topics in this chapter. It was busy. One of them was finding the rational zeros, or P over Q's. Rational zeros of polynomials. So if we have f of x equals ax to the n, where n is the biggest term, plus bx to the n minus 1, plus dot 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 dot, plus, I don't know. They usually go a0, x to the 0 here. E are factors of the constant. Because x0 is just 1, and this would just say, this will just have like plus a number at the end. It won't show x to the 0. And Q kind of is factors of this term. It's called the leading term because it's the one in front. And it's the one in front because it has the largest exponent. So we're looking for things with P over Q. So we'll try an example. Our example is gonna be f of x equals 6x cubed minus 37x squared plus 32x plus 15. So P comes from factors of 15. 15, we can do 1 times 15 or 3 times 5. Q comes from factors of the first one. We can have 1 times 6 or 2 times 3. So we're gonna put these together and make a list. Just pick one letter from P and do it over all the other numbers in Q. So we could have 1/6. And all of these are plus or minus because negative values work. I could have plus or minus 1/2. I'll go 1/3, that's the next lowest number. 1/2 or plus or minus 1. That's from doing the 1. That's where P factor is 1. Then if I do the P factor is 2, I've got 2/6, 2/3, 2/2, 2/1. So this is 1/3. And we already have 1/3 right there, so we don't need that one. That's a double. 2/3 is already simplified. 2/2 equals 1. And we have that up here, that's a double as well, so we don't need that one either. And we look at P equal, why did I say P equals 2? P didn't have a 2, what am I doing? Yeah, 1, 3, 3, 5, 15. 1, 2, 3, 6. I'm over here trying to do them and I fucked it up, so I don't have them in order. Alright, so the next one in P is 3. That's what I should have done. I've got plus or minus 3/6, plus or minus 3/3, plus or minus 3/2, plus or minus 3/1. I still have the plus or minus 1 is right here. I didn't mean to cross that out up there. Let me put it back in. This is the plus or minus 1 up above, and this is the plus or minus 1/2 up above. So we don't need that one either. We don't have a 3/2 and we don't have a 3. P equals 5, we got plus or minus 5/6, plus or minus 5/3, plus or minus 5/2, and plus or minus 5. And none of those simplify. And none of those are duplicates. Here we could have 15/6, which is 5, this is 5/2. So that's a duplicate. Then I got 15/3. But that's 5, that's a duplicate. I've got plus or minus 15/2, which is not a duplicate, or plus or minus 15. There's a lot of numbers here. Let's start organizing these. Okay, so, oh shit, this is ugly as fuck. Let me make a list of what some of these numbers look like as decimals. Those are all less than 1. This is 1.5. This is 2.5. What is this? This is 2.67. That's 0.833. 1/6 is 0.167. That's 0.33. I'm on the screen for those. Bring that back down. 0.5 for that. And 15/2 is 7.5.
You got something 15/3.
Yeah, because it's the 5 here. If you do 15 divided by 3, it's 5. So we already got that on the list. So our negative numbers from lowest to highest. I've got -15, -7.5. That's not 2.67, that's 1.67 right there. I've got -2.5. Oh. -5 is the next lowest. -3. Get those, I did that, I gotta get that one. -2.5, -1.67, -1.5, -1. -0.83, -0.5, -0.33. And -1.67. Those are all the negative ones. Maybe I'll put that down there. Nope, not -1.67. -0.167. All right, then we got the positive ones that go in the opposite order. 0.167, 0.33, 0.5, 0.83, 1, 1.5, 1.67, 2.5, 3, 5, 7.5, and 15. It's important to note that if I use these numbers, the decimals, some of them are not going to give me a 0 whatsoever. So this one, we want to use 5/3 here. And the negative version there. And positive there. For 8/3, we want to use 5/6. This is 1/6 and 1/3.
Wait, why did we do that?
Because if I plug in a decimal, we need to see which of the ones are trying, we're testing these to see which one is if these equal 0. And if I round it at all, which I did for these. The board, the bottom has a factor of 3 in it. I had to round to get a decimal. Which means when I do synthetic division, I'm not going to get a 0. Because I've moved it slightly away from the actual answer. So you want to use the actual answers when you're testing these. All right, so our coefficients were 6, -37, 32, and 15. These have got some big numbers, so I'm gonna start with like a big number. We start with maybe a 1. 1's kind of high up on this list. It might work, let's see. One didn't help. So I can cross off 1. We're trying to get a 0 at the end. And if we can get these to be all positive, we know we don't have anything higher than it. That was the boundness theorem. We start with a positive number here, and if these are all positive, we don't have anything bigger that's positive. So maybe start with like something like 5. Maybe we can eliminate. And that's a little high. Let's go to 3. Let's give 3 a try. Hey. Good. Oh, I knocked it out. Yeah. Thank you. All right, what is that? -19? This is getting ugly fast. This is clearly not going to be 0. We still have numbers that are not positive above it, so I can try a bigger number. I'll try a 5. Five worked. So x equals 5 is a 0. Which means x minus 5 is a factor. You missed a rough day, probably the hardest day. The rational zeros section, it's a long section. We're still working on it more today.
Sucks.
So to run you through it real quick. When you have a polynomial, the zeros are where f of x can equal 0 and have a rational, like a fraction as an answer, come from factors of the last number over factors of the leading coefficient. So we went through and made a list of all the numbers that are factors of 15 and all the factors of 6, and did 15 factors of 15 over factors of 6. And we made a list and we put them in order. There are specific rules that kind of help you when you're doing synthetic division. One of them is if you do a positive number out here and every number down here is positive, it means there's no number bigger than it that works. So you can cross off a bunch of zeros. If these are all positive, nothing higher than it works. So you can cross off a bunch of zeros. So it's not ideal to start like with the top number. Starting with like a whole number somewhere in the middle reach. These weren't all positive, so I said, well, I don't wanna work, a lot of these are fractions, I don't wanna work with fractions. So I just kept going and trying the whole numbers, 1, 3, 5, 3 didn't have all positive, so it still didn't say I couldn't have more. So 5 was the next option and 5 worked, when it's a 0 here, that's the remainder, that's what works.
When they're all positive, what?
If they're all positive on the bottom row and the number in front that you're dividing by is positive. There are no answers that are larger than that number,
Larger than 1?
larger than 1. So if this had been positive 31. I could have crossed off everything after 1. Well, that's not after 1, that's part of that. If this one's negative. And they alternate. Then there's nothing more negative, there's no numbers that are more negative.
What do you mean, like if they alternate, like positive, negative?
Yes, positive, negative, or negative, positive, which one is the sign? This would have to start with a positive because this number starts with a positive. Once we have the answer, I'll go through and find a number that shows the negative thing real quick. So. Our 6x cubed. Just for a pause here. Can be written as x minus 5 times, and then we have whatever we have left over here with one exponent lower. That's a cube, so we'll do a square here. 6x squared minus 7x minus 3. We're not done factoring it because the zeros are where all these equal, where like this is a 0, that's a factor. But now that we're down to a quadratic, we don't need to try all this synthetic division for 25 numbers. We can use quadratic formula, or a times c is negative 18. It needs to add to negative 7. So we can do 1 and negative 18, that's negative 17. 2 and negative 9 adds up to negative 7. So let's split this up. We got 6x squared minus 9x plus 2x minus 3. And we'll continue factoring. This pulls out a 3x, leaving behind 2x minus 3. There's no common factor between these two, so plus 1 times 2x minus 3. And we get x minus 3 times 3x plus 1 times 2x minus 3. Not x minus 3, x minus 5. That number just changed shape. So our zeros set each of these equal to 0, x equals 5, or when you do that one, negative 1/3, or when you do this one, x equals 3/2.
So once you find,
Once you get it down to 2, or there's only 3 things here besides the 0, you're down to a quadratic formula, and it's easier to use that. Or a quadratic equation.
so that way you can skip all the,
Yeah, we still have a lot of numbers to check here. I mean, notice they show up on the list.
right,
Negative 1/3's there and 3/2 is right there. They're there. But like, that's fucking 20 numbers to check. This is an operation that works and you know it's gonna get it to the answer right away. There's no like, I'm using paper, we're fucking burning trees. It looks like negative 1/3 was the lowest. Let me see if I can find an example where like. Because none of these numbers worked after it. So let me try like negative 1 in the original. Let's see what negative 1 would have done. This would have been a great one to start with. This is an example of the boundness theorem. That's what it was called. This was one of the two options. That's negative. These alternate signs. Which means we could, if we had started with that number rather than positive one, I could have come up here and crossed all of these motherfuckers off. All of a sudden the blue pin's working better.
Is that always for the boundness theorem? The number outside is. Can it be positive or negative?
So the positive version of the boundness theorem is this. That's like this is like the B version, the A version is the positive version. If it's a positive out front. And the bottom is all positive. Then nothing bigger, which makes sense because you're gonna keep. Well, when you multiply it, you just keep adding bigger numbers. You're adding, there's no way to go negative. Another test you can do, it was called Descartes' theorem. In fact, I should have led with this. Let's look at what Descartes' theorem says for this. So Descartes, his was the sign changing theorem. This is not called the sign changing theorem, even though that's part of what we count with. So the number of times f of x changes signs was our number of possible positive answers. Roots, they're called. And then number of times f of negative x changes signs. Is the number of possible negative roots. We started off with 6x squared minus 37, or 6x cubed minus 37x squared plus 32x plus 15. This had one sign change, two sign changes. So this is f of x, just regular f of x. So there's at most two positive answers. Now, I think doing f of negative x is a waste of time, but but it doesn't mean that what I'm about to say doesn't hold true every time. The total number of solutions is the degree of the polynomial. I'm off the screen. Is the degree of the polynomial.
So in that case, it would be 3.
Yeah, in this case, 3. If 2 are positive, how many are negative? 1. That should hold true every single time. So I don't see the point in doing this f of negative x, but I'm wondering if there's a case where it's like, oh, we know an answer is 0 and 0 doesn't count. Maybe I'll have to design it. Let's try that in a second. But just to show the f of negative x in this one, it's worth doing. Because a lot of people will mess this up. Everywhere you plug in x, you put in negative x. These stay negative. Even after we deal with parentheses. That stays negative. This one turns positive. And it's based on the exponents. Even exponents, the negative becomes a positive. And odd exponents, a negative exponent negative stays negative. So if I apply that here. Oh, that's a minus. It only changed signs once. So, but this is a lot more work. You gotta go through and like write it out what it is to figure out the sign changes. Here, you already have the damn equation. All you gotta do is count the sign changes. It's not a big step. Doesn't take any extra pencil work. Other than to maybe write down 2 positive roots. And then you can do a quick subtraction and find out how many are negative. And the way you can use that to your benefit is whichever has more possible roots. Start with those P over Q. And the easiest way I can explain that is if you had 2 bags filled with rocks. And one you needed to draw, they're all white rocks except for the answers are black rocks kind of thing. And one bag had more black rocks than the other bag, and you need to draw a black rock. You're gonna draw from the bag that you know has more black rocks. Because you're more likely to get a black rock. Same applies here. There's more answers to hit with random checking. So you might as well start on that side. Thankfully, I did on this problem.
Such a long process.
It is. A lot of the last page and a half of what I wrote is just helping speed shit up. We actually. If I wasn't writing with a pen. This would have been maybe a page. Maybe a half page, 2/3 of a page. I'm writing over here with supersized fucking lettering. Yeah, it's still long though. That's why I led with you guys may or may not like this. It's a lot of work.
So you said that, you wanna keep it fractions if it's like divisible by 3. Right? Or,
If when you put it in a calculator, you get an unending decimal.
right,
So not just 3, but like 7 works that way. 6, 11, Basically, any odd number you divide by except for one, you're well, 5, you get like 0.2, 0.4, so that's not true. But there's a lot of numbers when you divide by the number. You get an unending decimal. And you don't want that. It does help though, in terms of putting them in order. Cause then you can do that cross off check. We were able to cross off -1. And we got rid of -3/2, we got rid of -5/3, we got rid of -5/2, we got rid of -7/2 or 15/2. We got rid of a lot of stuff. But if you don't have it as, if you leave it as a fraction and not as a decimal, you may not know that you can cross that one off. Now, for the one that'll be on the final, and there will be one on the final. It's only gonna be an x cubed. I'm not gonna do something horrendous like an x to the 5th where you gotta fucking find 3 of them before you get down to a quadratic. That might make a fun extra credit problem.
Oh, did you, grade midterms?
Nope. Still waiting for a couple of people to finish and we're doing makeups. And I will get them.
Makeups for this, I didn't know we had a test. I think we had a test, right? For this support class.
You just asked if I graded them already.
No, the midterm, there was like a test before this, for the midterm.
No, we didn't yet. We just had a midterm. Oh, the support course has like the online thing.
Yeah, that one. I don't think,
I haven't gone through and graded it because I think it auto grades it, but I, before the end of the semester, before I submit actual grades, I'll go through and check it. I can tell you right now, if you're in the support course and you get you're not getting worse than the grade you get in the main course.
okay.
So like if you,
I could still take
if you
it,
do-
I could take it.
I think you still can. So seeing as how that was a long process, let's take a pause on that. We'll do another one in the next class.
Just to make sure I read this right, you said that if it is a positive